Hello everyone, welcome to the third interview in the Leetcode series. First thing first, you may have noticed that we changed the series name to Leetcode. That's because we want to emphasize that this series is about doing coding exercises with us. The content is still the same. We will put these coding exercises in a mock interview setting, like what will happen in real life. So this time we have a new grad with us, and this is the first time we have a new graduate in this channel. He is a CS major, and this is his first coding interview, so it will be a very interesting and exciting experience. Another thing I want to make a change to this series is that I moved the feedback session from the end of the video to the beginning. In this way, you can first learn where the interviewee did great and where his weak point is. And you can take these insights with you when you watch this interview and learn from it. Now let's start with the feedback session. For this interviewee, the positive thing I want to point out is that clearly he's well prepared. He can point out the optimal solution very quickly, and this shows that he has practiced a lot in his spare time. For me, as an interviewer, I would feel that he cares about this opportunity. Therefore, I would encourage everyone to open up Leetcode and try to resolve as much coding problems as you can before your future interviews. However, there are two things the interviewee can improve on. Firstly, although he has done this question before, he could not implement the solution correctly. We spent quite some time drilling into the details of his implementation, trying to make it work correctly. This leaves us with no time for the follow-up question, and there was simply no time for me to ask him to reason about the time and space complexity of his algorithm. Also, I want to stress that the coding exercises are not only about your technical ability, but also about your communication skills. There were a lot of times I tried to take him to the correct solution, but I think these hints I tried to give to him are lost on his side. This is not a good sign to show that you can work as a team to resolve coding problems together in your job. You can think of your interviewer as your colleagues, your friend. What you should try to do is resolve this coding question together with him.
So I'm going to give you a small example and a small problem for you to solve, and then please try use an algorithm to solve it. Actually, so the question is quite simple. So you are given two inputs. So one input is a string. So for example, apple, pen, apple, right? So you are given this string, and then you are given a dictionary. So you are given a dictionary as a list of strings. So you are given apple and then pen actually, and then you are asked. So if you can, so if S can be segmented. So if this S, it can be broken into parts. It's broken into smaller parts where each part is one or each part is a word in the dictionary. So for this example, it can, right? So because S equals apple plus pen plus apple.
Okay.
So, but suppose if we change S slightly, so if we change apple to apple, so pear apple, and
Okay.
if we keep the dictionary the same, then so this should return false. This should return true. So this is a true case. But suppose if S equals this, and then the dictionary, if we change the dictionary is the same, then so you should return false because there's no way you can break up this string into smaller parts where it's made up by this dictionary. So this should return true and this should return false. Is this question clear to you actually?
I have some questions like the size of the input string will be like what?
So the input string, you can suppose like the input string will be from 0 to probably 10 to the power of 4, 10 to the power of 5 or 6. Like it won't be a very large string, but like it will be something like a 10 to the power of 4. So the length of s so is equal less or equal. Yeah. And then similarly, like the dictionary, so the length of the dictionary is similar, I think. Yeah. So like these like are just made up numbers, but like they won't be too large, but like they can be they're it's definitely like large, but they can be too large. So yeah.
Okay, so so our output will be true or false if the our string could be split or segmented by the word in dictionary.
Yeah.
Okay. So all right. I think the problem is pretty clear. So what we need to do, like a very naive approach for this method, this problem is like we can use depth first search backtracking to list all the combinations of words in dictionary, and each time we get a combination, we need to check with our input string if it is totally it is matched string, so we can return true. And otherwise, we just to keep backtracking and list all the possible combinations of string. Like, but in this approach, I think the time complexity will be very huge, because we need to list all the possible approach. I think in this problem we can to reduce the time complexity by use dynamic programming. I think we can check with the input string, and we can store the word in the list input string into a data structure like hash set, and to check if it is contained by the word in dictionary. And we can assume an array named dynamic programming like DP, and DPI may represents if the word from 0 to I is in the dictionary. In the dictionary. So in this way we can reduce the time complexity to check to reduce the time complexity to check if all the possible combinations of words in dictionary. So is it clear? Do you think any?
So you mentioned that you can use a DP I to represent the words 0 to I is in the dictionary. But like what's usually in dynamic programming you need two things. You need a state and you need a function which takes you to the next state actually. So can you tell me what's your next state actually? So for example, if J is larger than I, then how do I get from I to J actually?
Yeah, I think it's a very good question. I think if we can check if DPI minus G is true or false. If it is false, we just I think we can just jump out from the loop. I think because we need to search in the search the whole imported string, and if our I mean the size the substring like from the substring from I minus G to I, if it contains by the if it is contained by the hash set, or which means we have the corresponding word in the dictionary, we could return the DPI is true. Yeah, this is my basic idea.
So you need to. So basically, you are going to check. So like I don't understand how you. So how many J's do you have to check in this case for DPI? So like do you check just one J? Do you pick a random J, or like what kind of J? What's the what's J here actually?
Okay, so J could be the. I think it could be. G is from the 0 to, and G can be small, can be large than I. So we need to check the former index, the from index of I.
Yeah. Cool. I think I get your idea. Actually, I think like it's on the right path. So can we try implementing this method, this function, and then can we try like run some like small examples with this function? Yeah.
Okay. So basically, we can like we can call function like public. And our input will be a string and dictionary. In what was the type of dictionary in?
So
I mean list.
Yeah, it will be just a list given when it's given to you. Yeah.
Okay. Like dictionary. And we could need to. The first step of our implementation will be we need to store the word in word dictionary. So we need to like we could write a hash set.
So why just why are we using a hash set? Why a list is not good enough in this case?
Because the list doesn't have the function contents. We need to check if our segmented word in our input string is contained by the word dictionary.
But what's wrong with so you said like a list doesn't have the method contains, but but what's wrong with me like going through the list every time and check if the words is if I can just so basically I can just write a for loop, right, and then check it myself.
You're right, but I think the hash set is data structure that can reduce the time complexity, because if we want to check the contents, it just need 01 time complexity in hash set.
Yeah.
It can reduce the time complexity. So I think in here we can I just come up an idea that we could check so we code to add each word in the hash set. And we need to add word. And so the next step is to, after we add all the wording to our site, we could write our dynamic programming array. Like this array, in this array, it will be a Boolean type, because we need to check if it's true or false. The word from 0 to I is in the dictionary. So we will write to data programming. Like the size will be this one, and we can check the last index in S. And so what we're going to do is like the dynamic programming, DP0, which means we don't have any, we don't have, haven't checked any string here. So our initialized state will be true. Yeah. Is it clear? Should I explain?
Yeah, I think so. Yeah.
Okay. So what we're going to do in the next step is to like check the string one by one, and we put we segmented. We will segment the word in string to check with hard set. And for the next, I think we need two loops to check if the 0 to I is contained by word in word dictionary. We also need to check if the I minus G to I, this segment is also contained by the word dictionary. So okay. So for here, what we're going to do is to if our former state, the I minus G is equal to false, which means it doesn't, it is not the part of word dictionary. So we just continue our loop, and if the DPI minus G is true, we code to check if the set contains the part from I minus G to I.
I don't really understand this part actually. So why, if it's false, and we can continue actually, like why that's the case?
I think like we need to because our like like we can take an example.
Yeah.
Like this apple pen.
Yeah.
Apple.
Yeah.
And our output, our word in dictionary will be apple. It's word dictionary. So in our two for loops, we need to check from like this one to A to move the pointer, and I is from P because I started from 1, and 0 and J will be here, right? But in our hard side, the word in word dictionaries, if we just like segmented A and P, it doesn't contain, it can't be checked by the hard side because we just have two characters. We need to segment like the whole word. We at least we need to move the I to like E to get the APPLE to get a word, and then we can check if it is contained by word dictionary. Is it clear?
So, but that's not related to this, right? Like, because DP IMSJ, I don't understand why, like, how that's related to DP IMSJ actually. You are, I'm not sure. Like, are you telling me like you need to check the length of this word, or?
I think
Mm-hmm.
yeah, you know the
Because
PowerPoint will
you said DPI is if the word I is in the dictionary or not, right? Like then what does DPI minus J mean here? Like what's its meaning?
sorry, I can't hear you.
So you said because you said DPI is means the word from 0
Sorry?
to I. Hello. Hello.
Can you hear me?
Yeah, I can hear you. Yes. Hi.
Hello?
Hi. Hello.
Hi.
Hello. Can you
Hello,
hear me?
hello.
Hello. Can you hear?
Yeah, I can hear.
Yeah. So you said so basically you said DPI is if the word 0 to I is in the dictionary or not. So what does DPI minus 1 I minus J mean here actually?
Okay, so yeah, DPI minus G will be like the index from G to I, the segmented string is in the dictionary. If the segmented string is in the dictionary, I think it's a definition. So if it is this definition, I think. Okay, so could I write all my code and
Yeah,
I
please.
will
Yeah.
explain it.
Yeah.
Okay, so
Sure.
let's
continue and then let's discuss this. Yeah, please. Yeah.
Okay. The next step is to check if the segmented part is contained by site. We need to search. And if it is contains by this site, we just make a DPI be true, and then we break. We don't need to check the string after the string after the index tree, and we can end our to for loop, and then we will return like the next index to check if the whole string, our input string, is satisfied our definition of word break. Yeah, I think it's the whole code, and we can run the test case to walk through the outcome.
Yeah. Can you run through a test case for me, please?
Yeah. Can and word dictionary is. And we could first step we need to create a hard set, and then we add the word in dictionary into our hard set. And our hard set will contain the same content in the word dictionary. We can just run as it. So then we need to initialize a Boolean array deep time programming, and then we assume the DP0 is true, and then we came into our main function. Like the index I is start from 1, which is, I think it's equal to I, this point. And for G, like it's from this point. And we first we came into line 29. We check if dpi minus g is false. I minus g is 1. 1 dp1 is not true, and we I think it is false because dp1 is what?
So you are at this line, right? So like you are at this line right now. Are you?
Yeah, I'm this line.
Yeah.
And we need to check if we jump or we just continue our for loop to move the index, and g is moved to equals to I, and which both of ig to pointer character p, and dpi minus g is 0 and dp0 is true. We don't need to come into this. We need to skip the first if statement, and we enter the second if statement. But the set didn't contain any from that last substring from 0 to 1. It doesn't. So we just go to next index for I to p, and we keep checking like this process until we get our I here. And J is 0, and dpi minus G is 4. It is 4, and it's false. It's true, and we need to check if the we also need to skip this if statement, and we need to enter the if check the segmented string apple is contained by hard set, and we check it is the apple app RE is in the hard set. We can DP4 is true. V4 is true.
Let's drill in a little bit actually. So here I equals so this is right. So let me write this down. So this is 0, 1, 2, 3, 4. So here I equals 4, right?
Yeah.
And then j equals according to the algorithm, j equals 0 in the beginning. So dpi minus j equals dp 4 equals 0 equals because you haven't, because this equals false here. So it's false, then we should continue. Like we shouldn't go into this checking. Does that make sense?
Yeah, you make sense. I think it's clear.
So you will move j again. So I think in this case.
All right. You're right. Maybe we can. Maybe you can switch the two. I think we can switch to if statement. If statement substitution to. We can firstly to check if it contains by hard set, and then we can check if the DPI minus J is false or not. If it is, we just continue our for loop. So what do you think of this code? We can make DP4 is true, and we DP4 is true because as the hard set did contain the word apple, and then we enter the second if statement, and DPI minus J is true, so we don't need to continue our.
This has another problem. So like first, if we do this, then we probably don't need this continue because it's not doing anything. Right? If we do that, so if we change it to this, we will be something like this. So because this is only doing continue and it's not doing anything, right? If we move it here. There's another problem with this. Is like I think you are quite close to get it right, but think about these. Think about like the condition you have set here. The meaning of this DPI actually. I think I encourage you to think about this. I can give you an example where if apple is not if the string is like this AAPL and PEN. So for example like that, and then when you have say when you have I here, so when you have J here, so J is at the PN side part, and then when I is at PN at the end of the string, so here substring I J will give you PN, right?
Yeah.
And then PN will be set to true. And then your DP here. So your DP. So there 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 10, 11. So basically, your DP here at 6, it will be set to true.
Yeah.
According to your according to this statement.
Yeah.
And then after some loops, you come to here, because then you move your. So I will give you. So I will after some loops, your J will be here, and I will be here, and then substring I J will equals to DP6 DP11 will equals to true. And according to your algorithm, then that's basically true, right? So basically this array is not correct. So like this array should return false, but your algorithm will return true in this case. So your algorithm will return anything that's ended with a word. Ended with a word with a word that's in the string. So it doesn't even matter what's before this apple. Like it can be just X, and it will return true actually. So there's something you need to add here. I think like you need some. Yeah.
You mean the definition of dynamic programming array is not correct? Yeah, I think so. I think we can modify the definition of our dynamic programming array. Could be like, or just to we could like
So maybe give you another hint. So still we need to go back to this. So to go back to the definition here, if the word this is correct actually. So like a DPI should represent if the word from 0 to I is in the dictionary, but like slightly not worded like that. So DPI should be the return should be the result of this problem in for string so this should be the result of the sub problem of this problem for word for s from 0 to I. So that's the definition of DPI. Then then like what's your state transfer function here? Okay, think about this.
Okay, so if DP, I mean, we still need two pointer, right? One is I, one is G. Yeah. If the DP, because the G is smaller than I, and if DPG is true, and I think our hard set also contains the segmented string from like J to I.
Yes.
I think it will return true.
Yes. So here, so transfer this. So let's try transfer this thought into code in line 30. So here you are just missing one condition check actually.
Okay, so I will just. Okay, so what we're going to do is to like DPI is like DPG, and because it's Boolean array, so we should make both of the two statements true. Because if we want DPI is true, we make DPJ is true, and we should make DP contents as a set contents, so string from G to I, and okay. So to avoid the example like you just said, it's space here. We need to, I think we need to check if DPI is true. If DPI is true, we just we need to skip the for loop. We could just write a break. Yeah.
Looks correct to me now. Cool. Cool. So I think we are running out of time, but like I think we basically got the problem correct. So I think this should be the end of the interview basically. So